So now we will discuss about the elementary counting technique. This is one of the most popular chapter from your syllabus, and a lot of questions are actually based on the elementary counting technique. Like something called pigeonhole principle. So pigeonhole principle, and also permutation and combinations are also originated from the elementary counting technique. So we'll discuss the basic of the elementary counting technique and also see what are the basic fundamentals of the elementary counting techniques, and then we will discuss the some of the questions, and then we can move towards the uh, pigeonhole and the permutation and combinations. Okay, so let's discuss this elementary counting technique. Okay, so like in the basic counting principle, actually we have two fundamental rules, which is called the product rule and the sum rule. Okay, so let's discuss what this product rule is all about. Okay, so talking about the product rule, suppose that a procedures can be broken down into sequence of two tasks. So let's say you are going to your school, okay, and you are going from your home to your school, okay, you're going from home to your school, and it so happens that to you have to go to point A, and then you have to go from point A to go to point a school. So let's say there are three ways to go to point A. Obviously there are three ways, three different ways, three different paths to go to point A, and there are four different paths to go to school from point A. So it may happen that this particular three and this particular four, so total number of ways, like how many ways you can go to school. So you can also pick this particular path, this path, and you can go to this path from school, or you can also pick this path but go this path from school, or you can choose this path for a school and you can choose this path for a school. So it is saying that suppose a procedures can be broken down into a sequence of two tasks. This is so broken down into sequence of two tasks. Then if there are n1 ways to do the first task, and each of these ways are doing the first task, and there are n2 ways to do the second task. It's saying that there are n1 ways to do the first task. There are n1 ways to do the first task, and for each of these way, means whatever the way you choose, let's say you choose this first way, the second way, or third way, whatever the way you choose, you can also repeat the second task by n2 number of ways. So total number of ways to complete the procedure is n1 into n2. So total number of ways you can go to a school is 3 into 4, which is equal to 12. Okay, so this is called the product rule, and the product rule is the fundamental concept. Actually this permutation comes also originated from this rule. So it is saying that obviously let's discuss once again. It is saying that if there are n1 ways to do the first task, and for each of these n1 ways, means let's say for first ways you can do this particular by four ways, for the second way you can also do this by four ways, and similarly that. So for picking any of these tasks, this first ways, there are n2 ways, means there are n2 ways to do the second task. So total number of ways is n1 into n2. So let's discuss on this example, and this fundamental product rule will be clear. So a new company had just two employees. Okay, it has two employees, Sanjal and Patel, and rents a floor of building with 12 offices. How many ways are there to assign different offices to these two employees? So it is saying that there are 12 offices in the floor of building. 12 offices are there. Okay, 12 offices are there. So there are two employee only. Okay, so it is happening that like the first employee. Okay, first employee can choose any of these 12 offices. Okay, first employee choose can any of these 12 offices, and second employee can also choose any of the second offices. Okay, so it is saying that a new company with just two employees, Sanjay and Patel, rents a floor of a building with 12 offices. How many ways there can be to assign each different offices to these two of employees? So different offices is talking about. So first employee can take any of the 12 offices. Now, if a particular employee, Sanjay, um, choose a particular office, then total number of ways to choose for the Patel is 11. Okay, so total number of ways is 11. So total number of ways is 12 into 11, which is equal to 132. Okay, so how this particular thing is working? It is saying that there are 12 offices on a particular building. Okay, means 12 offices. So they had to choose different offices. So obviously, for Patel or for Sanj, for any to choose anyone, let's say we choose Patel first. So Patel have 12 choice to pick any offices. So let's say he has a choice to pick any office, he choose a particular office. Let's say he was assigned to this particular office. Now there are only 11 unique offices left where no one belongs. So out of those 11 offices, this particular banda Sanjay can pick any offices. So total number of ways to do this thing is 12 into 11, because in any of these 12 Patel choose, and after choosing his any one of ways his this particular employee choose. So total number of ways 132. Okay, let's see some other example. There are 32 microcomputers in a computer center. So 32 computers are microcomputers are there. Each microcomputer has 24 ports. So obviously it is saying that there are 32, there are 32, there are 32. Okay, let's say there are 32 computers, and for each computer there are 24 different ports. Okay, 24 different ports. How many different ports to a microcomputer in the center are there? How many different ports to a computer? So let's say you choose the first computer. Okay, so there are 24 different ports. So 24. You choose the second computer. There are also 24 different ports. Okay, 24 different ports. Obviously choose the third computer, there are also 24 different ports. Okay, so total number of ways, what is asking, how many different ports, how many different ports to a microcomputer in a center are there? Obviously each microcomputer has 24 different ports. Okay, and there are 20, 32 different 32 different particular microcomputer. So total number of ways is 24 into 32. Okay, so this is the basic examples of product rule. Okay, now there is something called extended product rule. So we are only talking about dividing the task into two parts. Means let's say you are going from home to school, so home to A, and then A to school. So there are two parts. But it is saying that suppose that a procedure is carried out by performing task T1 to Tm. Means now it has been divided into m different tasks. Okay, and it is saying that the procedure is carried out by performing the task T1 to Tm in sequence. Means first T1 is performed, then T2 is performed, and let's say each task Ti, means out of this m task, each task Ti can be done in the ni ways. So it's saying that T1 can be done by n1 ways, T2 can be done by n2 ways, T3 can be done by n3 ways. Similarly, Tn can be done by, sorry, Tm can be done by Nm days. Okay, it may happen. Let's say you go to a grocery store and you are buying a soap. Okay, so let's say there are 10 different kind of soap. Then for oil there are, let's say, five different kind of oil. For what I can say, for different thing, I can, let's say, for cream there is a special kind of cream. Let's say there are seven kind of different cream. So out of this, means what are the different ways you can choose a soap, a oil, and a cream? So obviously you can choose a soap by 10 ways, obviously you can choose a oil by 5 ways, and obviously you can choose a cream by 7 ways. So total number of things is 10 into 5 into 7. So this picking up means shopping at a grocery store is actually divided into three tasks: soap, oil, and cream. Soap can be chosen by, means there are 10 different type of soap. So soap can be chosen by 10 ways, oil by 5 ways, and cream by 7 ways. So this is saying that if means the total Ti task can be done by Ni ways, then regardless of how the previous tasks were done, there are N1 into N2 into Nm ways to carry out the procedure. Means obviously it may happen that, let's say, you choose oil first by 5 ways, then you choose the cream. Let's say you may choose cream first, then oil, then soap. So obviously whatever the order is, or it's saying that regardless of how the previous task was done, means there are total number of ways to carry out whole procedure is multiply all the possibility, like n1 into n2 into nm. Okay, so let's discuss this particular thing, and then it will be clear with examples. Okay, it is saying that how many different license plate can be made if each plate contains a sequence of three uppercase English letter followed by three digit. Okay, so we know that we have 26 English letter, and we have 10 different digit starting from 0 to 9. Okay, so it is saying that how many different license plate can be made if each plate, means each license plate contains a sequence of three uppercase English, means three uppercase English, and followed by three digit. Obviously, this three means and saying that no sequence of letters are prohibited, means obviously any sequence of letter can be there. Maybe all letters are same. So first three letters can be chosen by, so first positions, let's say there are six, means obviously it is a six plate number plate, six sequence number plate. Okay, there are so it is saying that if each plate contains sequence of three uppercase English letters, so there are 26 uppercase A to capital Z. Okay, so this can be filled by C 26 which any one of the 26 letter you can pick. This also can be picked by 26 ways. This also can be picked by 26 ways. Now, so coming to the digit, there are only 10 digits. So this can be picked by any 10 digits. This can be picked by any of the 10 digits, and this can be done by any of the 10 digits. So total number of ways is, you can actually multiply this particular formula, particular thing, and you will get the result whatever the result is. So this is the way actually find total number of so thing is that, like the product rule is all about if we're doing different tasks differently, and obviously each thing is required. Means obviously you need to choose this first letter by 26 ways, this you also need to choose this first letter by 26 ways, something like that. Okay, so let's me discuss some different type of example. So example is, what is the value of k after the following code run. Okay, so means the particular piece of code is written for you here, and it is asking about the value of k when a particular code is run. And what is given? N1, N2, Nm are the positive integers, and this particular code has been executed. Then what is the value of k? Okay, so let's discuss the code. So k is equal to 0 initially, and there are nested for loop. Nested for loop is within a for loop. Okay, there are different for loop. Okay, so means within a for loop there are different for loops. So within a for loop, this loop, then this loop, then this loop. So there are total nm loops. Okay, so you can see that, just go to this particular this part. Okay, so like, let's see this particular code for two loops. Okay, for I1 is equal to 1 to n1. Okay, and inside this particular thing, from I1 I2 is equal to 1 to n2. Okay, just see this, the two loop only, two nested loop, and k is equal to k plus 1, and k is equal to 0 initialized. So for each I1, for let's say I is equal to 1, so this particular code will be running n2 number of times. Okay, for I from 1 to n2. So k will be getting increased from 1 to k is equal to 0, so k will be getting added 1 each time. So it will be k is equal to n2. But obviously for this particular line of code is actually getting run by n1 number of times. So for I is equal to 1 also, this is n2 number of times. For I is equal to, this is n2 number of times. For I is equal to 2 also, this is getting run n2 number of times. For I is equal to n1 also, it is getting run n2 number of times. So total values of k is equal to n2 plus n2 into n1. Why? Because n2 means 1 is getting added n1 number of times. Means this particular n2 means, let's say n1 is equal to 5 and n2 is equal to 4. So if I is equal to 1, this particular k is equal to k plus k is equal to 4. Now if I is equal to 2, then it will increase to plus 4 more, 8. And similarly, if it goes till 5, it will be 4 into 5, which is equal to 20. Okay, so if you have two loops, two nested loop, then k is equal to n2 into n1, because this thing is getting repeated each number of times. For I is equal to 1, getting repeated into number of time. For I is equal to 2 also. For I is equal to 3 also. So if you have a nm nested loop, then this particular thing is going to run as nm into, means obviously you can just assume it n1 into n2 dot nm. So this is the correct answer of this particular code. Okay, so you can see that if you just visualize it by using two nested loop, it will be getting clear for you. And obviously you can do it by taking n1 is equal to 5 and n2 is equal to 4, and you can see that whatever the result is going to be. So at each point of time, one is getting added, and it is going to be nested loop of nm loops. That was what value is going to be uh, k is equal to k plus 1, and value is going to be n1 into n2 into nm. Okay, now comes the sum rule. So what is the sum rule? Let's say a task can be either done in one of the n1 ways or in one of the n2 ways. Okay, now there we have a and word. Okay, and means a particular task is getting done by n1 ways, and after completing that particular task, it is getting done by n2 ways. But here the thing has been changed. It is saying that a task can either be done by n1 ways or can either done by n2 ways. So let's say you go to a school, and uh, it may happens that, okay, just not take the example of school, let's take some different example. Okay, you go to the grocery store, and let's say soap is equal to soap, 10 soap are there, uh, 7 oil are there, 7 different types of oil are there, and cream, 5 different creams are there. Okay, so you means someone asked from your home to just bring only one product. Anything you can bring only one product. So either you can buy one soap out of 10, or either you can buy one oil out of 7, or either you can buy one cream out of 5. The total of is 7, 5, 12, 22. So out of 22 items, you can buy just only one item. So how many number of ways you can do this? You can just simply add all the items. Obviously you have to find a single item. Obviously if you find one item from each of the things, you would have multiplied those things. Okay, so the thing is, if a task can be either done by n1 ways or n2 ways, where none of the set n1 ways is the same as the set of n2 ways. Obviously, this soap, oil, something are different. Then there are n1 plus n2 ways to do the task. So obviously, some tasks can be done by n1 ways or n2 ways or n3 ways. So what you need to do, add all the particular thing, and this is the number of ways you can perform the task. So I think it will be clear from the examples more. The example is, suppose that a member of mathematics faculty, obviously just put your attention on or here. Okay, a member of mathematics faculty or a student who is a mathematics major is chosen as a representative to university committee. So either thing is that either this would belong to the mathematics committee, or either the student should be a mathematics major. So either a faculty is there, either a student is there, anyone can be there. Okay, so how many different choices are there for this representative if there are 37 members of the mathematics faculty and 83 members of the majors. So it is saying that the total 37 faculty are there. Let me change the color. Okay, 37 faculties are there. Okay, and total 83 students are there, mathematics major student. And you have to choose a member, means you have to choose a what do you have to choose? You have to choose a representative to a university committee. You have to choose a representative to a university committee. So this particular thing can be done by like either a faculty can be chosen, either a student can be chosen. So total 37 plus 83, because or keyword is there, and similarly either the student can be chosen or either the faculty can be chosen. So total number of ways will be, if you add those particular thing, and whatever you get the answer, that particular thing will be there. Okay, so whatever you get the answer, so you have to apply this particular way to give the some counting principle. Obviously, you'll find a lot of examples in the R.D. Sharma also, or Kenneth H. Rosen book that I have told you. You can also solve a lot of questions from that. Obviously, you can also find a practice sheet along with this lecture on the website. Go to the tutorial academic website, and you can also download a lot of different practice questions from this particular part. Okay, now let me discuss the extended sum rule. The same thing like extended product rule we have, now we can also have extended sum rule. So what is the extended sum rule? The extended sum rule is, suppose that a task can be done in n1 ways, uh, in one of the n2 ways, or in one of the nm ways. So total number of, now the particular thing is about n1, n2 and nm. Okay, where none of the set ni ways of doing the task is the same as the none of any of the set n. It means that everything is a different. Everything is a different. Okay. So it is saying the total number of ways to do the task is n1 plus n2 dot nm. Okay. So this is the n1 plus n2 plus nm. So this is the subscript. This is the beginning. This is not the multiplication. This is not the multiplication. This is the n1 n2 plus nm. Okay. So a student can choose, let's say just discuss some examples. So the example is, a student can choose a computer project in one of the three lists. The three list contains 23, 15 and 19 possible projects. So let's say there are 23 projects of one kind, 15 projects of second kind and 19 projects of third kind. And he had to choose a single project out of all those given. Okay. So it is asking about how many possible projects are there to choose from. Okay, so obviously it's like he had to choose only one project. Okay, no project is on more than one list. It's not like if some project is in the list also, this is also present in this list also, this is not there. So 23 project of one kind, 15 project of second kind, 19 project of different kind, and he had to choose only one project. So obviously he can choose it by 23 plus 15 plus 19. So this is the basic counting principle. Okay, obviously I have a different questions from you also. The question is, okay, the question is, what is the value of k after the following code has been run? Okay, what is the value of k? So the same question that we had, but the fundamental has been changed. So now also obviously k is equal to 0. So this is a particular for loop. Okay, so this particular for loop is from 1 to n to the second for loop. Obviously these are not nested for loop. Okay, not nested for loop. Okay, so not nested for loop. So thing is that from I2 is equal to 1 to N2, and obviously last loop is from 1 to N. So after this first loop is executed, the value of k is going to be N1. Okay, because 1 is going to be added N1 number of times. Okay, after this particular value has been, this particular for loop is executed, k is equal to now N1 plus N2, because N2 number of more 1 is going to add it. And similarly, after this last loop is executed, the particular value of k is going to be n1 plus n2 plus nm. Okay, so these are all the value of k that is going to be. Obviously these are not a four nested loop, because if it would have been nested loop, this particular answer would be there. Okay, so now let me discuss you some more of a difficult example of obviously this counting principle, and then obviously you can solve questions from R.D. Sharma, or obviously you can download the sheet. I have just downloaded the sheet from the Kenneth H. Rosen book. So there is a book called Kenneth H. Rosen for discrete mathematics. So I've downloaded the sheet from that particular book. Obviously you can download the sheet from the website. So the thing is, let me just change the color. Okay, the each user on a computer system has a password. So whatever the question is, each user on computer system has a password which is 6 to 8 character long. It means that either the password can be 6 character long or 7 character long or 8 character long. So it depends on user whatever the password is going to give. He may give the password of 6 character long, 7 character long, or 8 character long. Okay, now the thing is that each character is an uppercase letter or a digit. So obviously in a password, it is saying that either the letters are uppercase letter, means capital A to capital Z, okay, or it is a digit. Digit means from 0 to 9. Okay. Now what it's asking, each password must contain at least one digit. Obviously it is saying that this particular password that you have, either 6 to 7 8 character long, each password must contain a digit. It's not like that. Let's say you are getting a b c f p k, so this is a 6 digit password. This is not acceptable because it is saying that at least one digit must be there. What is the questions, how many possible passwords are there? So it is asking about how many possible passwords are there that you can make from this particular fundamental concept. Okay, so let's discuss about the questions and what is the given, and then we will discuss about the answer clearly. Okay, so correct, let p be the total number of possible password. Okay, obviously p be the total number of possible password because passwords can be either 6 character long, 7 character long, or 8 character long. Okay, so we have to find the 6 character long all password, 7 character long all password, and 8 character long all possible password. So this denote the p denote the all possible password. Okay, all possible password. And P6, P7, P8 actually denote the number of possible password of length 6, 7, and 8 respectively. So this thing is there. Okay. Now the thing is that we can do represent it is by P is equal to P6, P7, P8. So obviously we need to find all the 6 length password. Obviously either can be the 7 length password or either can be 8 length password. Okay. Now P6, to find P6, it is easier to find the number of string of uppercase letter and digits that are 6 character long, including with no digits. Obviously, no, like let's say there are 6 character password. Okay, just pay attention to this particular formula, this 6 character password. Okay, uh, so it is saying that there are 6 character password. So 26 letter are there and plus 10 digits are there. Okay, so total 36 letter are there. So obviously, this particular positions can be filled by 36 ways. This can be filled by 36 ways. So total number of possible ways are 36 to the power 6. But in this particular case, it may happen that all the possible positions are being occupied by a string, or it may happen that some of the particular places are occupied by a string and the digit. So thing is that you have to find all those password that is actually had us at least one digit. So how do you find that? You will find, let's say we subtract all those password actually have only string in that place. So let me happen that A B C K C, this is C, K, F, P. This 6 digit password which does not have any digit. It may happen that B, A, C, Z, Z, Y. Okay, this is also 6 word password which does not have any digit. So in this part, it has been included all the password which have uppercase letter, digits, also with no digit also. And these things are also no digit. But we have to require at least one digit should be there. So what do we find? We minus 26 to the power 6. So what is 26 to the power 6? If we find, we know that 26 letter are there, 26 string are there, 26 characters of alphabet are there, and if you just want to fill all the positions with a single letter alphabet, total number of possibilities will be 26 to the power 6. So this thing is given to us. So obviously either fill any letter from A to Z here, any letter from A to Z here, something like that. So if we minus this particular thing, we get all the particular password which have at least one digit, at least one digit. And how we are ensuring that? Because we are subtracting all those sequence, we are removing all those sequence which have only the a string. We are removing all those sequence. So now whatever the left in this particular part, it will give you the all those passwords that have at least one digit. Similarly, we do this thing for the sixth, we do this thing for the 7 digit, and do this thing for the 8 digit. And obviously we all those things to get a number. Obviously don't worry about the calculation. In the exam we won't ask you to write this calculation, but obviously you need to write this particular thing that you understand. So this is the way you can actually solve this particular part. Obviously just read the solution, and I think you can actually solve this part. So the thing is that you can obviously download a sheet that I have given you. There are a lot of practice questions, and you can practice the questions from the counting principle. So there are only two major things, that's the product rule and the sum rule. And obviously any questions you can solve on the basis of product rule, sum rule. Obviously permutation combinations concept can also be based on this product and sum rule.